So, okay, so thank you very much. Let's start this ratio, proportion, rate and work. In fact, in this, what we are going to discuss total is, what is the all topic we'll discuss. Let me write in the complete manner. Ratio, proportion, variation, rate and work, and time, speed and distance. Time, speed, comma, distance. Time, speed and distance. So this topic is very interesting and very powerful topic. Here I'm going to use a variation approach. Okay. So as I said, this topic is very interesting, very important. Anything not clear to you, just stop me, and until you get full clarity, don't move. Until you get full clarity, don't move. The topic is ratio, proportion, variation, rate and work. Just a minute. I'll go like this. Yeah, what is this happening? Yes, now it's better. So what is ratio? If I ask you one line definition for ratio, how you are going to define a ratio?
Like the relation between one amount or one quantity and another?
Yes. So let's see, let me tell you one very simple definition of ratio is comparison. Ratio is comparison between similar quantity. Ratio is comparison between similar quantity. Okay. Right. Or in the simple word, we can say ratio is equal to fraction. Ratio is equal to fraction. When I say the ratio A is to B, let us say is 3:4. Does it mean A is 3? This also can be written as a fraction. A by B is equal to 3/4. Does it mean A is 3, B is 4?
No. It could be maybe 9 and 16.
Yes. So it could be not 9 and 16. It could be when you multiply by 3. So it could be 9 and 12. It could be 30 by 40. It could be 6 by 8. So when I say A is to B is 3:4, it doesn't mean that A is 3 and B is 4, right? In this case, what is the ratio between, when you see the picture here, what is the ratio between green apple to red apple? So basically there are 3 green apple, and how many red apple we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So ratio is 3/9, but you can cut further 1/3. So if I say what is the green apple to red apple ratio is 1/3, or we can say 1:3. It doesn't mean that we have only 1 green apple and 3 red apple. In the picture, it is very clear. We have 3 green apple and 9 red apple. So that is perfectly right. If the ratio given between A is to B is 3:4, it doesn't mean that A is 3, B is 4. But still, I wanted to know the value of A. What to do? 3 into some constant term, whatever this. And how about B? B is equals to 4 into some constant term. Now, how to know the value of this constant term? You'll be given some additional information. And from there, we can figure out the value of K. Let's take an example. I'm going to take an example for this. A is to B, 3:4. So A could be 3K, B could be 4K. How to know the value of K? As I said, you'll be given some additional information. I will take one real life example. Let us say this is the container, contain 50 liters of solutions of milk and water. Milk and water. So milk and water, maybe ratio is given 2:3. Does it mean we have 2 liter milk and 3 liter water?
No.
The meaning here is whatever be the total solution, of which 2 part be the milk and 3 part be the water. Am I right? 2 part be the milk,
Yes.
3 part be the water. So let us say milk is 2K, water is 3K, and what is the milk plus water? 5K, which is 50. So what is K?
10.
10. And if I put that 10 here in the relation, first one, so you are going to get the amount of milk 2 into 10, which is 20 liter, and amount of water 3 into 10, that is 30 liter. We got. This is the way approach 1 to get the individual value of milk and individual value of water. Now there is another approach. There is another approach, and that second approach we can get directly the value of milk and water without using any constant K. Let's see how. Milk part is, Frederick, see here, total solution is 50 liter. What is the milk
Yes.
part? 2. How we do is 2 divided by total. And you can see directly you'll get 20 from here. How about water? 50. Water part is 3.
3.
So 3 divided by 2 plus 3. So we are getting 40. Maybe in the first look, it looked like this is the better approach, right? In the first look, it looked like the better approach. But is it really better? I would say no. One must know both approach, not only one. You must know this approach, and also you should know this approach.
Okay.
Now, a simple question to you. A simple question to you. How many liters of milk should be added to this solution? How many liters of milk should be added? How many liters of milk should be added to this solution to get equal ratio? Equal ratio. Can you? How many liters of milk should be added to this solution in order to get equal ratio? What be your answer?
10.
Congratulations, correct. Because if you add 10, in that case, water will be 30 and milk be also 30. And the ratio of milk is to water be 30 is to 30. That is equal ratio. Or we can say 1:1. So in fact, 1:1 is called equal ratio.
Okay.
So let me remind you once again, what is the ratio? Ratio is a fraction. What is ratio? Ratio is a fraction. Now I'm going to ask 2 questions. Be careful. Most of the students get wrong answer here, but Federico is going to get right answer.
A lot of pressure there.
Oh, I thought I'm relieving pressure. I'm creating pressure, right? Oh, very sad. Okay. Now, at present, milk is to water ratio is given how much? 2:3. I'm talking the same solution. At present, milk is to water ratio given 2:3. If milk is to water ratio doubled, if milk is to water ratio doubled, then What is new ratio? Can you tell me? Don't get pressure. Get down, sir. At present, milk to water ratio is 2:3. If milk is to water ratio doubled, then what is the new ratio?
1:6. No, no.
No, you're right. No, it's wrong answer. Think. If milk is to water ratio doubled, so what is the new ratio? That's the reason I said, remember, ratio is equals to fraction. At present, what is the fraction you have? 2/3.
Yes.
It became doubled. So what is the new fraction?
4/9.
Doubled.
Sorry, 4/6. Sorry.
Frederick, still wrong. I'm not saying just double this fraction. If any fraction given 2/3.
Okay. 4/3.
4/3.
Yes.
This new ratio is going to be 4:3. As I said, if you remember, ratio is equal to fraction, then there is no confusion. So if the milk is to water ratio, no. If the milk is to water fraction doubled, so this way we can,
Yes.
Let me go in the second condition. If milk is to water ratio half, then what is new ratio?
Is 2:6. Is
1:3.
1:3. Yes.
Congratulations, it's correct. I hope this is clear.
Yes.
Good. Shall I close this?
Yes.
Now we discuss properties of ratios. Properties of ratio. Let's say any ratio is to be given. So the first property is ratio multiplied by a constant term ratio remains unchanged. So A is to B will be same as AK is to BK, provided K is not equal to 0.
Okay.
Any ratio multiplied by a constant term ratio remains unchanged. You want to take an example? 30 is to 40 be same as 30 into 10 is to 40 into 10. Don't you think both are same? 30/40 be same as 300/400, and if you simplify, both are 3/4.
Yes.
Second one, ratio divided by a constant term ratio remains unchanged. Means A is to B be same as A/K is to B/K. Again, provided K is not equal to 0. So take same example. 30 is to 40 be same as 30/10 is to 40/10. Isn't it? Because this is 3/4 and this is also 3/4. Take care, one thing here. The same is not valid for addition and subtraction.
Or the, sorry, I didn't understand. I didn't hear.
I'm saying the same is not valid for addition and subtraction. Up to here.
Okay.
Federico, up to here is clear.
Yes, yes, yes.
Okay. I'm saying the same is not valid for addition and subtraction. So A plus K, this may not be equal to B plus K. This may not be equal. Similarly, fourth case we can say A is to B may not be equal to A minus K is to B minus K.
Mm. Okay.
Clear. So I close it.
Yes.
Now let's see the composite ratio. We are going to compose, we are going to club two ratios. Maybe any ratio given A is to B, let us say 3 is to 4. Other ratio B is to C is given 5 is to 6. Can you club these two ratios? Or after clubbing these two, can you tell me what be A is to B is to C?
Mm.
I'm giving 30 seconds to you.
Okay.
If you do not have idea, you can tell me, I'll explain. If you have idea, go ahead.
I've been taking like common
Sorry?
denominator. I was thinking of taking like common.
I think you are on the right track, but execute this one and get the final answer.
Hmm. Is so it's
Okay, shall I explain? It's not
yes,
clear,
yes,
nobody.
fine. Yes.
See here, there are two different ratios. One is this, other is this. I wanted to club these two. I wanted to join these two. And who is the mediator? B.
Hmm.
You can see B is the common in both. So if this mediator is same, we can club these two. Now you can see in this side mediator is not same. This fellow is 4, this fellow is 5. Right? So this is not same. That's the reason we are not able to club these two. Now, how to club these two? Just try to equate these two. How to equate? As you know, ratio multiplied by constant term, ratio remains unchanged. If this number multiplied by 5 and if this number multiplied by 4, don't you think this be equal?
Yes.
4 by 20, 4 into 5 by 20. So what is the new ratio is to be entire things multiplied by 5. So 3 into 5 is to 4 into 5.
Hmm.
And second one is multiplied by 4. 5 into 4 is to 6 into 4. As
Okay.
ratio multiplied by constant term, ratio remains unchanged. So here I'm multiplying by constant term. So this is going to be now you can see this connector is same.
Hmm.
Now we can club. So what
Yes,
is
yes.
to be to see
15.
is to 20 is to 24. Correct. Okay, if I ask an additional question here, what is A is to C? What be your answer? If I
15
ask an
to
additional question,
24.
what is A is to C? Roderick,
Yes, 15 to 24.
correct. Can you reduce it?
Yes, 5 to 8.
Correct. So I'm very confident that it is very clear to you ratios and its properties, composite ratio, and properties of ratio, etc. Yes.
Yes.
Good.